Enterprise AI safety is not just about smarter models. It is about what happens when automation fails, behaves unsafely, or is abused. In this section, we connect fallback systems, human authority, training, and monitoring into one continuity mindset. We've already built the major control layers: architecture, identity, application security, RAG protection, supply chain, monitoring, governance, responsible AI, and compliance. Now we shift from design to operations, where failures, human decisions, and misuse put those controls to the test. Traditional continuity asks, is the system up? I continuity adds a harder question. Can we still trust the decision? An AI service may be online while producing false answers, exposing data, violating policy, or removing human judgment from the workflow. So fallback planning cannot be purely technical. It must define who takes over, which process changes, which model is safe to use, and what infrastructure keeps the business moving. Start by mapping where the business truly depends on AI: applications, models, APIs, workflows, and data pipelines. Then test realistic failure scenarios, such as a model outage, unsafe output, provider disruption, or broken data feed. For each scenario, define recovery time, recovery point, acceptable decision delay, and manual alternatives. This turns resilience planning into prioritization. So investment goes first to the areas where downtime, data loss, regulation, or customer trust create the greatest risks. Fallback is not one emergency switch. It is a set of operating modes chosen by risk. When AI is slow or uncertain, degraded mode keeps the service running with less automation. When capacity fails, an alternate provider preserves capability with added governance checks. For repeatable, low-risk requests, cached responses may be fastest. And when decisions must be explainable, rule-based workflows replace AI with deterministic logic. The goal is continuity without pretending every fallback has the same trust level. Degraded mode is the safety fallback for moments when full AI automation should not continue. The goal is continuity, not completeness. First, detect the issue. Then disable risky capabilities, such as autonomous actions, tool execution, or sensitive generation. Keep safer functions available, like read-only access, limited search, templates, or guided workflows. Tell users clearly that capability is reduced. Finally, log what happened, who did what, and when recovery occurred, so the system can improve after the incident. Provider failover is more than switching from Model A to Model B. Safe routing starts with options that governance and legal have already approved. The router then evaluates health, latency, policy limits, and data sensitivity before sending a request to a primary or fallback region. The same controls must follow every path: DLP, residency rules, guardrails, validation, logging, and contract terms. Without regular testing, resilience exists only on paper. During an outage, the safest fallback may be no generation at all. If a request is predictable and low risk, return a pre-approved response with an owner, expiration date, version, and validation record. If the situation involves regulated or safety-critical decisions, use deterministic rules instead of model judgment. The key is transparency. Label these outputs as fallback responses, and make their limits clear so users do not mistake them for fresh AI reasoning. When an AI service is down, stale, or outside policy, the right move may be to stop the workflow rather than guess. Non-urgent tasks can move into a queue with their transaction state preserved. Before replay, recheck context, permissions, data freshness, and approvals. If an AI action already changed the system and is later judged unsafe, rollback reverses it. Idempotency and audit logs make replay and undo predictable instead of chaotic. Manual override is not just a big red button. It is a governed chain of authority. Low-risk corrections may belong to trained users, while higher-risk actions require supervisors, compliance teams, or emergency stop owners. Every override should capture who acted, why, what evidence supported the decision, and when it happened. That protects the system from both blind automation and arbitrary human interference. Over time, override patterns can also reveal model defects, policy gaps, or possible misuse. High-risk AI recommendations should create a pause, not an automatic action. The system first classifies the decision by impact, reversibility, and regulatory exposure. Reviewers then receive the evidence they need: rationale, source material, confidence, and policy limits. For sensitive outcomes like lending, hiring, legal action, or account closure, approval may require a second reviewer. The goal is accountable action: approve, reject, modify, or escalate, with a clear audit record behind every decision. Continuity also depends on work that can continue without the broken platform. Critical teams need offline runbooks for support, fraud review, legal triage, and security response. Those runbooks should include manual forms, approval logs, contact trees, decision criteria, and recovery synchronization steps. Most importantly, they must be accessible, secure, and tested. Tabletop exercises and live drills reveal whether people can actually use them under pressure. AI security also depends on everyday choices. Employees need to know which tools are approved, what data must never be uploaded, how to prompt safely, and when to question an output. Reporting suspicious responses or accidental exposure should be simple, fast, and encouraged. Insider risk changes when one prompt can compress, transform, or move large volumes of sensitive data. Detection should not rely on a single tool. Watch for shadow AI use, unauthorized uploads, excessive querying, abnormal access, prompt-based exfiltration, and bulk summarization. Then correlate those signals with identity, endpoint, SAS, DLP, UEBA, and SIEM data. When risk escalates, root investigations through insider threat, legal, HR, privacy, and business leadership. Enterprise AI resilience is not just keeping systems online. It means layered fallbacks, clear human authority, practiced manual procedures, and users trained to handle data, prompts, phishing, and deepfakes safely. When telemetry connects with security, compliance, HR, and legal processes, AI becomes governable under stress.